In continuation with exercise 22b, question number 8, using the measurements given in the following figure, find the value of sine phi. Sine phi, this is the sine phi, and this is tan of this angle theta. Now in the figure, drop a perpendicular. A, B, C, D is marked. Drop a perpendicular DE. Okay? A perpendicular DE on AC. So construction. Draw DE perpendicular to AB. Okay, DE perpendicular to AB. Now, first we have to find sine phi. To find sine phi, we have to know DC, which is not given, and that can be found out using the Pythagoras theorem. Therefore, I'll do it here. DC will be square root of 13 square minus 12 square, which is equal to 169 minus 144, and this is equal to root 25 or 5. Therefore, DC is 5. Now, sine phi is perpendicular by hypotenuse, right? Perpendicular side is 5 by hypotenuse is 13. Hence, this is the ratio for sine phi. Now, coming to tan theta. To find out tan theta, we have to know the perpendicular side and the base. For this, the perpendicular side ED will be equal to BC, because these are corresponding angles. Therefore, if BC is 12, ED will be equal to 12. Right? These lines are parallel, in fact. This length will be equal because these are perpendicular drawn. Now, DC is 5. Therefore, if this EB, if it is 5, this part will be 14 minus 5. And 14 minus 5 is 9. Right? AE is 9. Therefore, tan theta is equal to perpendicular by base, that is 12 by 9, or 4 by 3. This cancels 4 and this cancels 3 times. So 4 by 3. Now the second part. To find AD in terms of theta. AD in terms of theta. AD is the hypotenuse. So this would connect sine theta, cos theta, all these, cosec theta, sec theta, any of these. Okay? Sine theta, cos theta, sec theta, cosec theta, any of these. I'll take it for any one. I'll take it for sine theta. Sine theta will be equal to what? Sine theta will be equal to 12 by 80. So AD is equal to AD in terms of theta. This implies AD is equal to 12 by sine theta, 12 by sine theta, or 12 cosec theta, 12 by sine theta. 1 by sine theta is cosec theta, right? This is equal to the reciprocal. You can write 12 by sine theta as AD, and 1 by sine theta is cosec theta. So this is part 2. Now, before I proceed further, let me explain these things to you. The reciprocal ratios. Cosec theta is the reciprocal of sine theta. Sec theta is the reciprocal of cos theta. cot theta is the reciprocal of tan theta. And also tan theta is equal to sin theta by cos theta. Alright? Please take it down in your notebook. You can also take a screenshot of this and write it down in your notebook. Next is, let me take up another question. Question number 10. If sin A plus cos A equals 2, find the value of sin square A plus cosec square A. Find sin square A plus cosec square A. This is not cos A, it is cosec A. So cosec square A. Sin square A plus cosec square A. To find sin square A plus cosec square A, what we do is, we are given the identity sin A plus cosec A equals 2. What you do is, square it on both the sides. Squaring on the left hand side, you will use the formula A plus B whole square, which is equal to A square plus B square plus 2AB. Applying this formula, sin A here becomes sin square A, B square becomes cosec square A, and 2AB becomes 2 into sin A into cosec A, which is equal to 2 square, that is 4. Now just now I mentioned sin A and cosec A are reciprocal of each other. So I can write, in place of cosec A, I can write, I'll just rub out this part. In place of sin, now sin square A plus cosec square A plus 2 into sin A, in place of cosec A, I can write 1 by sin A, and this is equal to 4. So what happens now? Sin A and sin A cancels. Therefore, what's the value of sin square A plus cosec square A? Sin square A plus, this implies sin square A plus cosec square A equals 4 minus 2, which is equal to 2. Side cancels here, 2 remains. So it is equal to 2. Exactly on same lines, you will work out question number 11.